Hey guys, welcome to your 7-6 notes on exponential functions. By the end of the day, you will be able to evaluate and graph exponential functions and to put the exponent in exponential and the fun in function. Okay, here we go. An exponential function is something that looks like this. Y equals a times b to the xth power. Notice that x is your exponent, putting the x in exponent, and it's still like a y equals kind of a function guy. So that's great. Here a and b will just be whatever, be whatever. Be random numbers, not random of course, they just define what the function is. A we call our initial value. You know what, I'm going to make this dark green because, well, I'll finish writing it and then I'll make it darker green. Initial value, initial meaning what it is at the start. It's going to be like the first value in your sequence or whatever. It's what happens when x equals 0. Because if x equals 0, then this expression right here becomes 1, and 1 times whatever is going to be that thing. So our y value, when x equals 0, we call that our y-intercept. Crazy, right? So a is actually going to be equal to your y-intercept. Fun fact, that's so fun. And then b here is the rate at which it grows. Sometimes it's growing, it's getting bigger. Sometimes it gets smaller, and that's a decay because it's decaying. So I'm not going to write growth or decay rate. It's just rate, whatever it is. Okay. You know y and x are your coordinates. Cool. Sometimes, just for full disclosure, sometimes you might get a plus c. That's plus a constant. Just, yeah. And that will affect your y-intercept. But for now, don't worry about this. Just know if it is plus something, it's still exponential. The reason that this function is exponential is because x functions as x is an exponent. So there you go. Okay. So what this looks like is if you have, let's say you have some graph, you have some function y equals 2 times 2 to the xth power. Okay, you could totally go through, you know what? Let's do it. Yeah, we'll do the long way, and then I'll show you the shortcut. Okay, so if you wanted to graph a function like this, you could always make an XY table. As any good graph goes, you want to have some negative values. You want to have 0. You want to have positive values. You plug those in and you figure out what y is. I'm going to start at x equals 0 because you get 2 times 2 to the 0th power, which is 2 times 1, which is 2. 2 times 2 to the first power is 2 times 2, which is 4. And then going on, we get 8. And going backwards, we have 1, 1/2, and then this is 1/16. If you don't believe me, you can plug those in. Okay, now that we've got our x values, that's going to be the x coordinate of a point. We've got our y values, that's going to be the y coordinate of our point. Nice. Okay. So we'll go ahead and plug those points in. We have -5. Oh my goodness, that's a little baby. 1/16. -2. Oh, little baby. 1/2, but not as small of a baby. Okay. -1. 1. We have 2, 4, 8. Oh, this guy's growing fast. Oof, look at this guy. That is not a line. This guy is very much a curve. But notice this guy right here just gets closer and closer to 0, but never touches. So it's like there's an invisible line right here. We have to make him dashed because no one actually touches him. This line we call an asymptote because it is not the same touching thing. It never touches this point. Okay, we'll say it has an asymptote at y equals 0, because that's where this is a horizontal line, so y equals 0. And we'll say that this graph approaches, because it gets really close to, it approaches an asymptote at y equals 0. Here an asymptote is a line that you get close to but never touch. I don't know if you've ever seen Emperor's New Groove, but this guy has a thing about not being touched, so he always goes, no touchy. So, yeah. Ta-da! If you have a constant, that'll move your asymptote up and down. Fun fact. Okay, cool. Now let's see, hey, is this thing, does this table or rule, does it represent an exponential function? Well, exponential function. Remind yourself, exponential function is where x is an exponent. So it's something that looks like y equals abx plus c maybe. But y equals ab to the x power is what we care about. Okay. Does this fit? Well, when we looked at our exponent, notice what b was. B was a rate. Is it increasing at the same rate? Here, when x increased by 1 every time, then y didn't increase by the same amount, it multiplied by the same amount because it's a rate. Rate is multiplication. So you get the times 2 every time because that's the rate. Okay. So we want to figure out as x increases by 1, which it's doing, does y multiply times the same thing? Well, here this is multiply times 3 times 3 times 3. Awesome. We're not adding 3, we're multiplying by 3 each time. So that makes this exponential. Now this guy, well, is he in the form y equals ab to the x power? Oh, shooties, my cuties. No, he's not. He's in the form of y equals m times x plus b, but b is 0. Okay, so that's a linear function because it's y equals mx plus b, which is a line. Yay. Okay, now let's graph it. You can always do a XY chart if you want. If you really want to plug in some X values, get a negative, get a 0, get positive, you can want to do a couple and do, great. I'm not because I know a shortcut. Now remember when you have y equals ab to the x power, to the power of x, let's get some of these guys in here to remind us what we're talking about. I don't recommend you copy. I think you should rewrite, but here we go. Okay, so our initial value is going to be 3. So that means when x equals 0, y equals 3. I can plug that in right now. Over 0, up 3. Boom. Y-intercept, nailed it. We also know our rate. Here our rate is 2. So we're going to take the guy beforehand and multiply times 2. So instead of having a slope, we're used to having lines where you have rise over run. I did this in the wrong color, but you remember slope being rise over run. And you go up something over 1, up something over 1. We're not doing that here. We are multiplying, baby. Okay, so we're going to take our previous guy, and as we go over 1, we're going to multiply times 2. So we need 3 times 2, which is 6, because our rate is 2. I covered it. Now do we want to go over again? We want to go over 1. We need to multiply times 2. 6 times 2 is 12. Oh, shoot. Wink. Okay, so if that's 11, that's 12. So our next point is over 2 up 12. Ha ha ha! We got it. We can also go backwards. If you want to go backwards 1, instead of times 2, you need to divide by 2. 3 divided by 2 is, 1.5. Oh, yuck. Oh, well. Whap. And then same thing, we can go back 1, divide by 2, 0.75. Oh, okay, but you're noticing the shape. All exponential guys will have the same shape. Just like that. But where is his asymptote? His asymptote is still going to be at y equals 0, because he doesn't have a plus c or minus c. He didn't move up or down at all. So usually your asymptote is going to be at y equals 0. So make sure you don't go past that line. What this graph is not like this. Oh, sad day, always going down. No, it is, well, it is always going down, but there's a limit. It doesn't go down to infinity. It goes down to 0. Ha ha ha. Okay, let's do 2 more, and then we'll call it a day. Good deal? Now, like I said, you can always do an XY table. If you want to do an XY table, that's fine. In fact, do it and then check my work. Check that my points are right. But all we need to look at is our initial and our rate. That's it. So our initial value here is -2. So over 0, down 2. And then our rate is 3. So we're going to go over 1 times 3. I'm going to zoom way in. Sorry, I zoomed way in. I went over 1, and then we need to take -2 times 3 is -6. We're going to go over 1. No, we're not going to, because we'd go all the way down to 18. -18, and that's way off the charts. So let's go the other way. We can go back 1, divide by 3 to get -2/3. There. And then we'll go back 1, divide by 3, 2/3 divided by 3 is 2/9. Well, negative 2/9. And then we just keep getting closer and closer to 0. But from the other way, how fun is that? You know, thinking back, you guys should probably draw your asymptote first. Notice you have an asymptote. A do not touch me line, a no touchy line. At y equals 0. I'm going to call it that forever now. A no touchy line. Anyway. So it's infinitely close to 0, but does not touch. Gets a little farther away from 0, a little farther away from 0, a lot farther. Oh, whew, really far away. Ha ha ha! So this is exponential growth, but negative. Cool. We've been talking about exponential growth a lot. Now let's look at an example of the opposite of that. We've been looking at growth, and that's when if you have y equals ab to the xth power, if b is greater than 1, that's an example of growth. But if b is less than 1, that's an example of decay. Ooh, we use this in chemistry a lot. Fun fact. Okay, if we have 1/3 x, y equals 1/3 to the xth power, how does that fit into our y equals ab to the xth power? In this case, we still have y. 1/3 is our rate, because that's what's being raised to the xth power. And there's an invisible 1 right here. So our first factor is a 1. Our first point is going to be at 0, 1. Cool! Now our growth is 1/3. Oh my goodness. So as we go over 1, we multiply times 1/3, which is 1/3. And we go over 1 to get 1/9, 1/27. Ugh, let's go backwards. So we go back 1, divide by 1/3 is the same thing as multiply by 3. Okay, and then divide by 1/3 is the same thing as multiply by 3. 3 times 3 is 9. Okay, oh my goodness, look guys, we're doing the opposite thing. Instead of having a growth shooting off. We are just getting a little baby, guys. Little baby, close to zero, but like not literally getting there. Technically, when x is infinity, then we will reach our asymptote. But it's not really possible. So there you have it. That's an example of decay. Hey. So decay, growth, but that's a negative growth, and then positive growth. Ooh. Okay, so there you have it. Exponential functions are functions in which x is functioning, no pun intended, as an exponent. They're either growth or decay, and I hope you grow a lot and have fun on your homework.